Hello everyone, welcome. This is a class of ECE341, the probability and random process course. Actually, this is a makeup class because we canceled the class during the second week because of the strike, right? Yeah. So now I gave the first makeup, and today we will discuss the random variable, the Gaussian random variable. Yeah, I already have these. This is the appendix of the textbook. Here, right, appendix. This is appendix A. Okay, in the end of the textbook, it's a Gaussian distribution. Gaussian, yeah, Gaussian distribution. Gaussian distribution. Gonna make it a little bit large. See here. Yeah, Gaussian distribution. Here, Gaussian distribution. This is a continuous type random variable. The x can take value from negative to positive infinity, and this is a PDF. We can have a look in what is the graph of this one. See the Gaussian, right? Gaussian mu and sigma. Gaussian mu and sigma. The random variable has this distribution. We can write it this way. Then the fx of x, the graph, or looks like this one. Here the peak value will occur at x equal to mu. Yeah, we know this is a 1 over sigma square root of 2 pi. This is a e to the negative x minus mu square over 2 sigma square. When x equal to mu, you plug in, this part is 0. So the exponential power is 1. The value is this one. This is the peak value. This is a 1 over sigma over square 2 pi. Right. If x is not mu, this is not 0. So you have e to the negative something. E to the negative something. So it will be a value smaller than 1. You see, when x larger than or smaller than mu, this part is smaller. So it turns to be smaller and smaller. When x go to infinite or negative infinite, this power go to infinite. So e to the negative infinite, it is 0. So the both side the limit is 0, and it's symmetrically because this is a square, right? X minus mu square. So x larger than mu and smaller than mu, these two parts they are symmetrically. Yeah. So this is the PDF of this random variable, and we also know ex is mu, sigma, not sigma, the variance x is sigma square, and if you want, you can also have the standard deviation of x, which is square root of variance of x. This is just sigma. So this random variable is very good. You know these two parameters. Actually, these two parameters, they are just the mean value and the standard deviation. You do not need to calculate. You know what are these mu and sigma. They are just given here. Right. Okay, the notation. I will say in our textbook we write in this way. It's a Gaussian mu sigma, or if you check online, you can see this notation is just n of mu and sigma square. We call it the normal distribution. Actually, this one is more common use. People prefer call this is normal distribution. Yeah, you can also call it Gaussian. So the things like we say, the Gaussian 2 and 4. That this is normal 2 and 16, and normal like a 1, 9. This is a Gaussian 1 and 3. This is a sigma square. This is sigma. This is a sigma. This is a sigma square. So you use different notation, but this is simple, right? You just simpler. You just one letter N. That's it. And this you have to write the whole name, Gaussian. So the notation, this one is the most common used. But in our textbook, we use this one. In the book we use this one. Right? And then we can see, we look at the graph. You can see the graph. When mu is different, it will move. The center, the peak value will be different related with mu. And here the peak value, how large or small, depending on sigma. Sigma small, here will be large. Sigma large, here will be smaller. So the things look like this. We can have this one, this one, this one. So this is mu 1, mu 2, mu 3. It's a Gaussian mu 1 sigma square, Gaussian mu 2 sigma square, and Gaussian the normal mu 3 sigma square. The PDF. This is X, right? So we have these three distribution. The graph looks like this. The PDF graph looks like this. For different mu, it is just a shift. It's a shift. Right? It's a shifting. Right? And for the this is sigma same, right? Same sigma, same sigma square, same variance. And if we keep mu to be same, change the different value of sigma, then it will look like this one, this one, the same mu. So this is a Gaussian normal mu sigma 1 and normal mu sigma 1 square and sigma 2 square. This is a, let's say this is x1, this is x2, and this is for x1, this is for x2. The x1 we have sigma 1, and x2 I have sigma 2. The parameter mu are same mu. In this case, this is according to the case x1 has higher peak value, that means sigma 1 is smaller. It's like this. Right? It's like this. You make sigma to be smaller, then the peak will be more narrow, but the y is taller and narrow. Right? If sigma is large, then it will, the shorter, the length, it's not so long, not so tall, and but wider, right? Wider, spread wider. Okay. This is the definition. You can also find this from the textbook. Appendix. We also have a chapter, section about this. It's a, let's see, it's a page. I already find it. It is in the page 159, 156. Okay, here. Yeah, we have one section, whole section about the Gaussian random variable. And here give us two graphs. The parameters are here. So this one, the left one, mu is 2, right one, mu is also 2, so they have same mu. The center is at mu, the peak value is at mu, at 2. And then sigma. the left one sigma is 1/2 and the right one sigma is larger, it is 2. So for larger sigma it spans more wider, right? More wider but not so taller. And this one it is narrow and tall, right? So this is the graph of the PDF. Then how to calculate, right? We know a distribution, we want to calculate. The important thing is how to find the probability. X of a normal distribution mu sigma square. How to suppose X of a normal distribution. Now how to find the probability, like alpha smaller than X smaller than beta? How to calculate these? This calculation, this you see the definition. You see the definition. In the definition, the PDF looks like this. This one is hard to calculate by your hand. Even by a calculator, it is not so easy, right? You need the scientific calculator, not the normal calculator, right? You need the exponential power, you need square root, you find this value. It's not so easy. And actually this is just the density function. After you get density function, if you base on the density function to find the probability, it will be like this. This one, alpha smaller than x smaller than beta, it will be integration from alpha to beta, then the density function. Okay, this one. It is complex, not easy. You calculate this, it's not easy. Then we use the following way. We use table. Yeah, this one. This distribution is common used. We need a lot of calculation. We need to find this kind of things. So we use a table to find this probability. First one, let's use the table. The table is in the textbook. It's inside this section. It's here. And its name is the standard normal CDF. The CDF we have in textbook. Let me copy in this textbook. It's in the textbook. The page. What is page? Page number. One 143. Page number 143, and the table 4.2. This is one table, and we have another table here. Next page, and this is the table 4.3. Okay, I put the information here. So we have this. We use these two tables. Okay. Now the problem is how to use these two tables. Yeah. Table 4.2. It gives us two columns. One column is z, the other column is phi of z. Phi of z is what? This is the probability of z, capital Z smaller than lowercase z. This is lowercase z. Okay, lowercase z. This is capital Z. how to say, this is also lowercase z. Capital Z obey the normal distribution with mu is 0 and sigma is 1. And mu equal to 0, sigma square as well as sigma, both are 1. Right, in this case. So this is a table for this one. And you can see the value in the table. Right. So this side is Z. The most left column, they are Z. This is Z. And this is the second table. This is Q, not phi. This one is phi. The first table, I don't want to give command. Yeah, Z and phi Z. Z and phi Z. Phi Z is a CDF. Phi Z is the CDF. Phi Z is a CDF phi of Z. Yeah, actually, in the table is Z here. It's kind of typo. Yeah, it should be phi Z. Phi Z. And then the Z, the value of Z is run from 0 to, here Z run from 0 to 3. 0 to 3. 0 to 3. This is the first table. And second table, Z run from 3. You see, 3 even larger until 5 or 6. 5 until 5. Okay, let me put it here. Yeah. Z start from 0 until 3, not 3. It's just a little bit smaller than 3. And the table for those, we have two tables. Right? Oh, this is table for those 3. This is for those 3. This one Z until 4.99. It's 5, right? 4.99. Yeah, so this is Z. This Z starts from 3 until 4.99. Until actually smaller than 5. No more than 5. Right? Less than 5. We have two tables. Yeah. This one is Z and QZ, where QZ equal to 1 minus phi Z. Okay, so from the table, when you know Z, you can find the phi Z. Phi Z is the CDF. So from table, we can find phi Z if Z between 0 and 5. Not 5, smaller than 5. Okay. With two tables. 0 to 3 we use the first table, and 3 to 5 we use the second table. But second table, after you get your result, you need to calculate. Right? Phi Z will be 1 minus QZ. Right? You move phi to the other side, Q to this side. Alright, then from the table we can have phi Z. After we get phi Z, then we can calculate. We'll go back to our problem. We want to find the probability like this. Right? We want to find the probability like this. So this one, now, if x of a normal with mu is 0 and sigma is 1, we call this is the standard Gaussian or standard normal. If x obey the normal distribution, normal standard distribution, the standard normal distribution or standard Gaussian distribution, then we have the probability of these were equal to just phi of weight minus phi of R. That's it. And from table, both numbers, find them from table. Okay, example. X of a normal distribution with the standard parameters 0 and 1, and then the probability of like a 1 smaller than equal to x smaller than equal to 2. What is this probability? Okay, it is just phi 2 minus phi 1. And phi 2, we need a table. Go to the table, go to phi 2. This is 3, and 1 and 2. Sorry, 1 and 2. It's in the first table. 1 is here, right? 1 is here. 1 is here, and 2 is here. 2 is here. All right, these two numbers I can copy them to. It is 0.97725 minus phi 1 is 0.8413. So this is 97725 minus 0.8413. Why this is longer? Okay, 3. This is 40. This is 6. 5. Okay, anyway, 5 is actually 0. 5. Subtract, and 2 minus 3 is 9, and 7 minus 1 is 6. But I move 1 back, so this is 5. 7, 4 is 3. 9 is 1. Okay, I got this is 0.13595. Alright, we got it. Okay, then here if we want to calculate another one, like 1 smaller than x smaller than 4, this one will be phi 4 minus phi 1. And phi 4, what is phi 4? We have Q4. Actually, this time we do not have phi 4. We have Q4. Let's go to the table. The first table is about phi. We use phi, but phi too small. Sorry, I touched somewhere. This is a 1. Where's the table? The table should be in the page. I just make a record. It is 161. 161. It's here. Right. So when z equal to 4, oh no, this is 420. 4 is here. You see, it's 4. So we get a q. This is not phi. It is 1 minus phi. So Q4 equal to 3.1710. Oh no, 10. This is actually e10 to the e to the negative 5. 3.17 times 10 to the negative 5. Okay, this is phi 4. This is Q4. Q4 will equal to 1 minus phi 4. Q4 is 1 minus phi 4. So we can have phi 4 equal to 1 minus this value. What it is? This is a point. I need a 5. 1, 2, 3, 4, 3, 1, 7. So this is a point 9999683. Alright, so this is phi 4. This is phi 4. Then the phi 4 is here, right? Is a point 9999683 minus phi 1. And what is phi 1? We need another table, previous table. 1 is here. 0.8413. 0.8413. So minus 0.8413. This give us, I need to calculate it right here, 0.99 0.99996 and 64683 minus 0.8413 minus, so this 3, this 8, this 6, 9 minus 3 I get 6, 9 minus 1 is 8, it's a 5, this is 1. Okay, the probability it is this one, and 0.158. Okay, 7. I put 4 digits, 5. Yeah. Now we have this probability. Okay, so this is a basic way to use that table when the distribution in this one, the standard Gaussian. If this value are different, we need a different ways. And here okay, now we consider more complex case. The first one is, here you see the values alpha and the beta, right? Alpha and the beta. I want to find the probability between alpha and the beta, where x locate between alpha and the beta. Both alpha and beta, I choose some positive value. If they are negative, what will happen? Okay, so next. Another example. I still use x obey the normal distribution, the standard one. You write as this one is also fine, or the Gaussian is also fine. Same thing. And we consider the probability of -2 smaller than x smaller than 3. Not 3. 2.5. Okay. 2.5. That is 1. Just 1. Alright. Any number, right? I use 1. Okay. We want to find this probability. Now, here's a negative. You cannot find it directly from the table. Now, how to do it? Okay, we use this feature. For the CDF of N01, this is a phi. Phi negative z were equal to 1 minus phi z. Indeed, this. Yeah, this is more casely. Same z, lowercase z, same z. This is the same. So this one we know this is a phi of 1 minus phi of -2, and this phi -2 are equal to 1 minus phi 2. Okay, now we can calculate phi 1. Phi 1 we already have it, right? Let me improve this example. Phi 1 is, this is phi 1, right? It's a 0.8413. This is phi 1, and minus phi -2. Phi -2 is 1 minus phi 2, and phi 2 is phi 2 is this, right? This is phi 2. Phi 2 is 977, so it's 1 minus 0.97725. Right? Yeah, we can find them directly from table, but we already checked it, right? We already have them from table, so just like this. Then we do a calculation. What is this? Now actually this one minus, okay, -1 plus 0.97725. Yeah, I can do this summation firstly, right? 0.8413 and 0.97725 to 5. Here's 5, 5, 8, 11, and 18. Right? And then minus 1 is plus, then minus 1. The result is 0.81855. Now we calculate it like this. Yeah. Any question? Yeah, actually, do you have any doubt about this? Yeah, actually, the thing is like this. This is PDF of N01. And then the CTF. CTF will be look like this. This is CTF of N01. As a notation in the table, this is phi of Z. And here's a Z. Like this. Alright. This one, you see, this one is symmetrically. If here's a negative Z, if here's a positive Z, then this part and this part, same value. Here is phi of negative Z. This point. And this point is phi Z. And phi of negative Z equal to, now phi Z is this value. And here's the difference. Here's the difference. Difference between 1 and phi Z. 1 minus phi Z. This is 1 minus phi Z. This part. So this part, they are same. This part and this part, they are same. They're kind of symmetrical, right? You compare related with this one, these two are symmetrical. This one and this one is symmetrical. Symmetrical. Yeah. It's like this, right? So phi Z, phi negative Z, phi of negative Z is here, and 1 minus phi Z is here. These two are same. These two are same. Right. So this calculation is based on this. Now we can find the probability for any alpha and the beta for this kind of problem. Right? When we where's the problem? Yeah. When we want to solve this problem, we want to find this probability, no matter what are these alpha and the beta, but not too large. You know, our table alpha and the beta, you cannot over 5. At most to be 5, to be 4.99. 4.99. Beta cannot over 4.99. The alpha cannot lower than negative 4.99. Between positive and negative 4.99. Then we can calculate based on the table. Alright, now we consider the last case. In generally, if X obey a normal distribution mu sigma square, now mu sigma there will be any, not necessary to be 0 and 1, to be 0 and 1. Then how to, we want to find probability of X between alpha and the beta. How to do it? Well, we can check PDF firstly. It looks like this. Here's a mu, and here's a 1 over 2 square root of 2 pi times sigma, right? Of n mu sigma squared, and we compare with PDF of n mu 0 and sigma is 1. 1 squared is still 1. It looks like this. Right? Here's mu is 0, and this point will be 1 over square root of 2 pi. because sigma is 1. Then these two, what is relation? You see, we have a shift, right? We have shift. I can put it here. Here's a shift, and from here to here, this is scale. This is a 2 pi square root with a sigma. So this is a scale. Scale, right? Scale along this direction. You need times. You make it up. You have a shift. You have shift. You have a shift. You have a scale. You have shift. You have a scale. And you can also check the formula. But the thing is, x. Now x is this one, right? Let I say is z equal to x minus mu shifted by mu, right? Shifted by mu. X shifted by mu. X shifted by mu. And scale by the sigma. Scale by sigma. It's a sigma, right? You times a sigma. Sigma sigma. Let this one. Then z will obey the n01. Yeah. Do a shift, do a scale. Now remember, we should have some other courses we discuss a signal, a function, you do a shift, you do a scale. Then you can have the different, right? Something different. Now as any distribution, normal Gaussian distribution with sigma and mu as a parameter. Now you shift by mu and scale by the sigma. You have another z. This is also random variable. The z will be the standard Gaussian, standard normal. Yeah, that's very good. And this one can use the table. Right? Our table is for this one, so we can just work like this. All right. Now let's explain the detail by an example. Suppose x obey a Gaussian distribution with mu is 5 and the sigma is like just 2, alright, 2. But I use this notation. I put n here. Here you need a square. Also, you can also write it as n5 and 4 is also fine. Okay, suppose x obey this one. We want the probability of x between -3 to +3. No, not 0. That's a 2. Between 2 to 6. Alright. We want this probability. X between 2 and 6. 2 and 6. Now how to do it? Let z equal to x minus 5. Yeah, shifted by mu and scaled by this sigma 2. Sigma is 2. Sigma is 2. If I describe the problem use this one, you should know sigma will be square root of this form. If you write as Gaussian, it will be this one. This 2 is the sigma. So we have 3 ways to write this notation. Same meaning, same meaning. Then, according to the parameter, I have this one z. Actually, we have name. We call this is a like a standard or normalizer. Normalizer. Normalize. Yes, normalize. Let z equal to this. Then z will obey normal distribution, Gaussian distribution with parameter mu equal to 0 and sigma equal to 1. And the event 2 smaller than x smaller than 6. Now it will equal to write x as x minus 5 over 2. Now here will be 6 minus 5 over 2. And here will be 2 minus 5 over 2. Right? We do the same operation on all these three numbers. Minus 5 over 2, minus 5 over 2, minus 5 over 2, right? 6 minus 5 over 2, max x minus 5 over 2, 2 minus 5 over 2. So they are same. They are same. And this one we can calculate. The first is negative 3 over 2 is negative 1.5. In the middle, I define this is z, right? So this is a z. And the last one is a positive 1 over 2 is 0.5. Okay, so the probability of 2 smaller than x smaller than 6, this probability, or equal to the probability now is in terms of z is 1.5, negative 1.5 smaller than z smaller than 0.5. Okay, now we use the table because z is this one. We can use table. We can use table. This is a standard normal, stand-up Gaussian. So we can use the table. We have the table. Now we use the table. Use the table. This will be phi of 0.5 minus phi of negative 1.5. Phi of 0.5 we can find it from the table. Phi of 0.5 is here, right? So 6915. 0.6915. And phi of negative 1.5, oh, this is negative value. Here's a negative z. We know this will be 1 minus phi at 1.5. Okay, 1 minus phi 1.5. 1.5 z. Right. So it's a 1 minus 0.9332. This is a 0.0668. Alright, now we can plug in and use another paper. This is a probability of 2 smaller than x smaller than 6. I'm sorry, can't see. It's here. Right. 1 is probability. 1 is probability. I copy it again. This one now equal to phi of 0.5, which is 0.6915, minus phi of negative 1.5. Phi of negative 1.5 is 0.0668. So this is 0.6915 minus 0.0668. So 15 minus 8 is 7. Then 10 minus 6 is 4. 9, remove 1 is 8. 8 minus 6, I get 2. And 6 just going down. Okay, so this is a 0.6247. So we have the probability. We have the probability. Yeah. So okay. So here, let me give a summary. If x obey a Gaussian distribution, normal distribution with parameter mu and sigma square, then let z equal to x minus mu. Mu is just this mu. Sigma is this sigma. Then z obey a normal 0 and 1. We can use the table. Right. And probability of alpha smaller than x smaller than beta tend to be equal to probability now is alpha minus mu over sigma smaller than, here's x minus mu over sigma smaller than beta, beta minus mu over sigma equal to the probability alpha minus mu over sigma, some number. When you have number you can find what it is. Here's just z, right? Z is this one. Z is this one, smaller than beta minus mu over sigma. This is also some number. Right? Here I just put letters. You know, when you know alpha, beta, and mu and sigma, they are values. Okay, you get this one. Then this one will be Q of beta minus mu over sigma minus phi of alpha minus mu over sigma. That's it. That's it. And for the table, we should know something. The Q of Z, which is 1 minus phi of Z. If you find the value from the second table, Q table, you need to find what is phi according to this. Secondly, we know phi of negative Z equal to 1 minus phi of Z. So if Z is some negative value, you need to use these so that go to a, if this is negative value, you need to check table, but our table only contain positive Z's, right? So for negative Z, use this formula, you can find the value from the table. What else? Okay, that's all for today. Then see you next time. Next class will be in the classroom, the Wednesday's class. Alright, and this is the makeup I post online. Alright, see you. Bye bye.